Okay, so we have two stars here, so they will produce their own gravitational field, which will be attractive and towards the center of their masses. So what will be the resultant field along this line here? So let's start off with this point. So at this point, we'll have a gravitational field towards y, and of course the x gravitational field will be towards x. The field strength will be quite large, but because they are directly opposite each other, the resultant is a zero, right? The two gravitational fields will cancel each other out at this point. So at this point here, we'll get a zero gravitational field strength. Let's consider a position, say somewhere here. Now, at this position, this distance is further than this distance, right? So the gravitational field caused by y will be smaller here, right? Compared to here, this will be a weaker gravitational field. X will also produce its own gravitational field that's of course directed towards x. So the magnitude of the individual field strength is smaller here, but because they are not directly opposite each other, when you think of the vector summation, these two gravitational fields will add up to be something that's about this long, right? The vector will be about this long. So it turns out the field strength will be non-zero at this position here. So let's say, well, it used to be somewhere here, alright? Somewhere here. And if we go even further, then you realize that the individual gravitational field strength will be very weak, because the field strength varies inversely with the square of the distance. So because the individual field strength is so weak, the vector sum will also be weaker. So since the resultant field strength starts off from 0, then to non-zero and approach 0 again, right? When it's really far away, surely the individual field strength will approach 0 and the resultant will also approach 0. So 0, non-zero, approach 0 again, so the field will look something like this. Of course, the same story happens on the other side, so it's going to look symmetrical. Alright, so this is the kind of waveform we are looking for. It must be 0 here because they cancel each other out completely. Then it becomes non-zero and approach 0 as you go towards infinity. Ta-ta!